Hello, this is Eric from Next Gen CAM. I'm coming to you from the crossroads of America out in sunny Indianapolis, Indiana. I'm very glad to have you joining us for this session. Let's get into the details. Today, we'd like to talk to you about increasing your profitability with advanced turning processes. And joining me today from Next Gen CAM, I have Andy Barney, who has a wealth of experience as a mold maker, as a machinist, a programmer. He originally began with Delcam in 2008, and he is a fantastic teacher. I think you'll be excited to see what he has to show in a few minutes. Phil Jennings is also joining us. He started as a tool and die apprentice and has come to be very well known for his skill in the Swiss space. And lastly is myself. I'm one of the co-founders at Next Gen CAM. I originally started as a mechanical engineer, went back, got a business degree, and I just love working with customers and seeing them achieve long-lasting success by working with our solutions. I just got a call from HR, and I thought I should, I guess we have a last-minute update here, guys. Sorry, Andy. They said you needed to cover up there a little bit. Phil, sorry, I'm getting a text here. I guess I have to wear a mask too. All right, so we can continue now that we're safely all masked up. Let's get into the presentation. For our agenda today, we've really got 7 main parts to this. We're going to be talking about just some of the top problems that you might have or be experiencing in the CNC industry. And then we're going to talk about advanced turning and just talk about it in the sense of the industry and some of the preconceived notions and ideas people have about it. Then we're going to dig into some solutions in this space. One of the first ones, those is being getting a lot of the easy work in the shop to be done faster through automation. Then we'll dig in deep on turn mill and Swiss style lathes. Then we'll finish up with some advanced techniques and integrations that we can help provide to take your company to the next level, and end on skills and teamwork with a Q&A session. These are some of the top problems that most people would agree with when you think about the CNC machine tool industry. And all of us have been in a situation where we've experienced some of these different errors at one point or another. And it is tough to run a machine shop, to run it well, to cut some of the most difficult parts in the industry. And so you just look through these are a host of things that can come at you. One is selecting the wrong cutting tools and settings, programming errors from getting the part with the wrong strategy, or ignoring some of the things that are in your space around it, just taking care of the machine tool and maintaining it. The skills gap is something that's very real in our industry, where there's a lot of newer and younger folks that are coming online, and they really want to get into the industry, but it's really difficult. It's different than I was in engineering. You can always add a couple extra notes to your drawing and send it over the wall to manufacturing. But in manufacturing, we have to deliver 100% perfect parts that meet the print, and so it's really important. Another one of the issues you have is sometimes you're doing a lot of different operations or using multiple machines, and so clamping and fixturing and all of that comes into play as a key area that you can struggle with. Automatic tool changer problems comes up a lot, so you want to make sure you've got a good machine tool and a good machine tool partner. Want to make sure your machine's running efficiently, and you're keeping that spindle running as much as you possibly can, and obviously not to damage the machine. So these are some of the top things that are coming up, and we want to talk about ways to mitigate those and to help you build a more profitable business in this industry. When we think about turning in general, there's lathes. Most of us are familiar with lathes, and but as you jump up to more complexity, the turn mill is a great solution, because at this point you start to add in milling and turning into the same machine, so you can get a lot more done on one part, and you can handle small to large scale production with these types of machines. Moving a little further up the stack, you can also get into Swiss. Where this is a lot more with sliding headstock and fixed bushings. This sometimes can be a lot of high production of lots of parts. They're typically very complex, complicated. Usually there's smaller parts, and so Swiss is a great way to produce those parts. When you start thinking about this in your shop, you instantly understand, hey, as complexity goes up, I can make a higher profit in this industry. But the downside to this is most people start thinking about the risks. And what if I fail? And what if I break or hurt one of these machines, or I can't meet my delivery schedules? So a lot of people think of this in a linear fashion. And what we want to do today is help you to figure out how you can tackle this to reduce the risk and increase the profits. The first thing that we are always going to talk about is you got to take the simpler jobs in your shop and you got to finish them faster. So one of the things you want is you want a comprehensive solution that's intelligent, so you can very quickly take that lower end stuff, get it done, and get on to the next thing. One of the ways that we do that is with intelligent automation. So if you have parts, for example, we can take a Z direction on the part and just automatically program the whole part for prismatic parts. And we're going to show a turning example here in just a few minutes. But we want to use automated programming techniques that take a lot of the steps out of the equation that you're going to take, and take those automatic results and fine tune them if you need to, but you can get pretty consistent and repeatable results by using intelligent automation. Then you can take it to the next level. Let's say you've got a family of parts, or you've got different things that you know are coming through your process on a frequent basis. This is where customized automation, you can take this and start to take the skills that your best programmer is using. So you have someone who just really knows how to program maybe this part in the middle of the picture. They can put all the best programming into the file or into a process, and then we can use that on the next part and the next part that comes out. We also have intelligent automation. So let's say you're programming one machine and that machine's busy today. Well, let's just automatically take that program and put it on a different machine without making that a manual effort in your shop. Here's an example of some of the efficiency. You take this as an ice cream scoop, and doing this in a manual multi-step process, you're going to end up with about 30 minutes each on these for these 10 parts. And you just have more steps. There's more setup and rework and more potential really for error. Let's look at going and putting that into a turn mill situation where we're doing it all on one machine, doing it on one side of the machine, transferring it to the other. Now we're looking at 8 minutes, 33 seconds, but best of all, you've eliminated a lot of the types of errors and things that you would have seen in this scenario. So these are the benefits we start to see. There's no fixture creation needed. You've only got one machine in this instead of putting on two different machines, potentially getting two different programmers involved. And the results that you can start getting around tooling, setup, cycle time, all of that is a big deal in a shop where you want to keep that spindle turning and increase your profitability. Best of all is the satisfaction of doing this all on one machine. It just makes it more fun. It's more exciting. So at this point, I'm going to hand over to Andy Barney, and he's going to take you through two different examples. The first example, he's going to show you how to take those simple jobs and get them done fast. The second thing he's going to do is show you how to masterfully and quickly use a turn mill in a very efficient operation, knowing you're doing something safe at a low risk. Andy, over to you.
Welcome, everyone. My name's Andy Barney. I've been with Next Gen Cam for a little over a year now, previously working for Delcam and Autodesk through the acquisition. It's my pleasure today to share with you FeatureCam. What you see on the screen now is a completed machine simulation, and we'll talk about the benefits of what that gives you in a few moments. But I'm going to show you this part and another one to kind of give you an idea of the process. So you can see there's more than one turret involved, and we're doing this all in one machine, as Eric mentioned. So let me run this simulation just so you have an idea of what it is that I'm going to show today. So we see a machine simulation where more than one tool is being used. at all times. Currently, the sub spindle is empty the first time through the simulation. That would be true the first time you ran the part, but this part has been synchronized to split up the operations among the multiple turrets and spindles in order to give you that efficiency and all those items that Eric mentioned to make productivity in your shop better. So we'll see here in momentarily, we'll see an actual transfer of the part, which eliminates another setup on an entirely different machine. You're able to do all this in one go and come off with completed part every time. So I'm going to go ahead and speed this up for you just a little bit, and then I'll show you how I actually programmed this part and actually another little more simple part, just to give you an idea of how this works on this software. So this is Autodesk's feature cam that I'm showing you, and I will be explaining to you how this was done and how this was created, and we'll see the end result. So this is what we're trying to get to, and get efficiency and reduce errors and increase productivity. Okay, so I think everybody has a pretty good idea on that. So let me just move forward to how I actually program parts with FeatureCam. So FeatureCam is feature-based machining. So we'll look at a little simpler part here, and I'm going to show you how this works. Feature-based machining is a concept unique to FeatureCam, where you are not creating tool paths, you are actually creating features, which are shapes that are used to, are the shapes you're trying to machine. It includes all the operations necessary. For example, when you drill a hole, you might need to spot drill and drill that. If you need to ream it, you can do that. All those would be included in what's called a feature. So let me show you how that works. So basically, FeatureCam uses configurations. When you pre-configure these, you can change whatever settings you would like for any machine tool, any material type you want to do, and then those become the active attributes in a part document. So if we're talking about turning, all the parameters that would apply when you're doing a turn for the OD or a bore for the ID, these parameters will be in there. These are fully customizable. You can do more than one configuration. So if you have different machine tools or different depth of cut needs for materials, you can do all that. And so the milling and turning work together in turn mill. So there's settings for both. So let me show you how to create features really easy from a solid model. So on the left is the workflow to FeatureCam. So just like other Autodesk products, you see the ribbon interface, you see the view cube, and then this is our actual workflow over here. So once we have defined our stock, which is actually this, and use any geometry tools, the CAD in this case, the solid model is our geometry, then we would work through the steps. One of these steps is actually automatic feature recognition. Okay, so this is going to automatically detect features from the model that you can choose to keep or disregard and move on with those. So I'm going to run automatic feature recognition on this part. It's important to note that I actually have a setup on both ends of the part. This is the main spindle, and this is for the sub spindle. So there's the sub spindle setup, and this is the main spindle setup. So I'm going to run through the wizard. So FeatureCam is also wizard based, so it guides you step by step through the process, and you're able to work through it and make decisions along the way. So both setups are items I want to program for both the main and the sub spindle. You see that on setup 1, which is the main spindle, we're seeing that FeatureCam's identifying all of these feature types. So it sees a bore for the internal work, which I can highlight there. We see the face feature for the end of the part. We see the turning for the profile, and then some hole features around the part and down the center. So if this is something, if this looks like what it is you want to keep for this setup, you can just keep working through the wizard. So as I press next, you'll notice it will now prompt me for setup 2, which is on the sub spindle. Some of the features match up a little bit from what we already accepted on the main. So all these holes I am not going to keep, but I do want to keep the facing and the bore feature on the sub spindle. So I will keep those two, and I will just deactivate the ones I don't want. And I also don't need to turn the part because I did that on the first setup. So I'm going to press finish at this point, and you'll notice over in the part view of the toolbox, we have features for setup 1 and features for setup 2. The great thing about FeatureCam is because it is feature-based, it's automatically selected tools, which of course you can override at any time. It's using a set of settings to determine what tools to use, again, fully customizable. It's got the depth of cuts, the pecking for the drilling, and all those other items. And it also has feeds and speeds, and that's based on whatever my stock material is and what the tool is made out of. So there's a table that you can customize for surface feet per minute, an inch per rev for turn, or inch per tooth for milling. And you can completely customize that to fit your needs. So as Eric mentioned earlier, taking your programmer knowledge and building that into FeatureCam automates this process. So if I were to do a simple simulation on this, let's actually do a 3D rendering of this. And I'll kind of move this over out of the way and we'll watch that. One of the steps of the process is to simulate this, right? And to see the result. And when we get the result, we see NC code. And so based on your active post, you'll have the NC code that you're after, okay? So in this case, you see that I had some areas of concern. There's some tools that might not quite fit in there. So you have tool cribs as well that will help you, and you can see the software. If it doesn't find a tool, it actually prompts you for that, and so on. So once you have it actually programmed, the next part is to actually synchronize this, okay? So this is happening over here in the tool post, and you can see there are operations. These operations are all based on whether they're main spindle or sub spindle operations. This also needs a cutoff, which is a very simple process just to make a new feature and make a cutoff, and I'll show you that in a moment. But basically this denotes the color is main spindle, and so is the symbol for the spindle, and the color yellow happens to be for the sub spindle. So let me show you one of these right here. Same part with this in here, and the cutoff is in, okay? So the cutoff feature, it's actually really easy to create. You just create a new feature. You say, I want to do a cutoff. I also want to, here's my parameters. It's actually looking at the stock to determine the diameter, inner and outer diameters. We can transfer it to the sub spindle and set our parameters, how much we grab the part by, where we wrap it to before we slow down and grab it, and our actual pull distance. So if I show you the existing cutoff feature in here, you can see that it has these parameters for this particular part. So I'm cutting off this far. That's where my cutoff is happening on the part. My tool width is there, and then the amount of material I want to face off on the next part is added. So it's a simple mathematical calculation, and the parameters are defined that way. Okay, so this one has that in here. So we see that there is a cutoff in here. This is automatically synchronized, but these items are not. So we're talking about efficiency as part of this. We can see at this point there's 8 minutes and 15 seconds on the estimated runtime. You can actually look at each of these operations, and you can see the length of run and when they start. So the longer the bar you see visually here, the longer the actual runtime. So in this case, you see the rough pass is starting at 36.9 seconds into the process and has a total length of 1 minute, 36.5 seconds through. Okay, so we're going to make this more efficient. This is a simple drag and drop in the operation view of the tool post. So this part's a little simpler than the other one I showed you. So I can simply just drag these over and move these operations to the lower turret. Okay, so if I didn't have these, we would see this result. And I'll actually run a machine simulation for you here. Whoops, didn't get these. Drag these over here. Okay, put these here. Okay, so we have the process, and if I show you the machine simulation is used to check for any collisions that you might find. So if a tool hits into the part, hits into a part of the machine, hits another tool, it's going to actually do a collision and show you that here in the software before you get to the actual machine and damage it. So that risk is mitigated that Eric talked about. So you can see all the tools in this case are being done on this upper turret if I don't synchronize. and that time was 8 minutes and 15 seconds. So what I want to actually do, well, I guess we can simulate and show you the entire process and show you if you have a single turret machine that you can still take advantage of that and eliminate setting it up on a lathe and then a mill. And you can see both processes are done. Okay, so it repeats the simulation just again to show you that. And just as a reminder, once we're done with simulation, we'll have the NC code necessary to go run on the machine. So FeatureCam has really made this easy for me. I didn't even draw anything. I didn't pick a tool. I didn't do any of that. All I did was run feature recognition and use cribs that I want and my feed and speed table and my stock material, and it's made that process easier. So what I want to do in this case, to just kind of highlight the synchronization, is show you that while these operations are running, I want these to run, and that will save me some time. And so my time was reduced well over a minute, almost a minute 16 seconds on this cycle alone for this part. So that's basically free money for your shop because you're running in a more efficient manner. So that's how the synchronization works. So we'll run a simulation on that, and then I'll show you the other part that's a little more complex, how easy it was for me to program that as well. So again, a reminder of the simplicity of doing this. I'm able to synchronize all this. The tools move to the lower turret. I can assign them to any pocket I want or tool post location. So in this case, I actually moved a tool into a different spot to avoid a collision, which FeatureCam alerted me of when I first set up this part. So let's take a look at this part now. This part right here is the one that I showed you in the original simulation. So you might think, well, the other part was really easy. Let's see how easy it is to program something like this. So automatic feature recognition will actually go along the Z-axis and detect features. So let me show you what that does. So here's my part. Run through. I just have one setup on this particular part for now in the interest of time. It's extracted or recognized all these features. I can keep any of them or all of them that I want. All of these look good except for this one. This is an actual milling tool path that would take an end mill and cut with the side right there, which wouldn't work. So I'm just going to deselect that. So I get to make choices along the way, as I mentioned. I'm going to press finish. You're going to see all the features, which include all the tools, feeds and speeds, step overs, depth of cuts, pecking, all the items that apply. Again, as a reminder, coming from my active attributes in the document. So all that stuff is there for me. So I was able to get it. Now I have the bulk of the programming on this main spindle, but I don't have it all. So let me simulate and show you what I have. Let me slow that down just a little bit, guys, and see what that looks like. So we can see all the turning, all this stuff. It drilled it. It's picked a spot drill. It's picked a drill. I didn't have to do any of that. It's got some groove features and so on. Okay, so everything that aligned with my Z-axis is done. Now I have a little bit of work to do. So I have all these holes around the outside. You can see all of these. I got this little flat right here to deal with in 4 spots. So let me show you another form of feature recognition before I end my presentation today. So these are considered milling features. So I just press the new feature button to start this up, and I can choose either turning style, which I will show you briefly, turns and bores and holes and threading and bar feeds and all the things you would need on a machine like this, or the milling tool paths. So I want also have holes that are milling. So anything that's not on center or around the part is considered live tooling, obviously off the center line. So we need to do a milling style tool path. So I'm going to use what's called interactive feature recognition. So you notice when I pick a feature type, I'm able to select the feature recognition and I can interact with my part model and select things. So let me show you how this works. So again, working through the wizard, I can choose to find features that align with my Z. Those are already done. So I want things that don't align with my Z, and I can specify any angle that I want, or I can go normal to or perpendicular to a surface. But in this case, with holes, I can automatically find them all around the part. Now, at this point, it wants to know what kind of holes. Well, I want all the holes, whether it's a counterboard hole, a plane hole, different diameters, etc. So as I work through the wizard, I make that choice. I can see the preview of what it's got. I can select them all, or I can select only certain ones if I'm after those, just manually clicking. So I want all of these. Now, really all that's left is for me to make a choice on, do I want to drill these, or do I want to maybe pre-drill and then cut this more like a pocket? So if I don't want it to be a hole, I could deselect it, and then I could do that as another feature type. But in this case, I do. So I'm going to press finish. You see that now we have a bunch of patterned holes because there are patterns to align these. We get all the updated operations, tools, feeds and speeds, depth of cuts, step overs, all that stuff. So I'll just re-simulate for you and just go a little bit faster this time. And you can see the now updated simulation with all of these items. So if you tried to do this in traditional CAM software that's not feature-based, you could be here for a while, and you would really spend quite a bit of time if you tried to do this on the controller. So you can see where I'm at, and I have updated NC code to reflect what I have. Okay, so one other quick one I'll show you just so you can see it, and I want to maybe do these flats. So I'll do those, and I'll end with that for now, just for our time. I'll do a side feature, which is an open shape, and extract with feature rec. And this time I'm going to align my tool axis to find features aligned, find the toolpath that I want aligned perpendicular to that. So my tool, the tip of the tool will come down to this surface. So I've basically just aligned it. I'm going to either pick one of these methods where I can pick the side walls, pick the floor, whatever is going to work for me. I'll actually show you that. And I will pick this, and I will add those in. Whoops, excuse me. Take that one right there and add it in and hit next. And now I get to determine which side I'm going to machine on. And on the very next page, I get to determine the depth. But before I move on, FeatureCam's prompting me, because it's wizard based, to make sure I have the side control settings. So this is protecting you from making a mistake. I am. Currently, it's cutting too deep. No problem. I can interact with the model. Remember, this is interactive feature recognition. I can select those, hit next. It sets my depth, creates my operations, selects my tools, sets my feeds and speeds, all that amazing stuff. So instead of doing this 4 times, I will actually do another feature called a pattern, and I will take that feature and pattern it around the index axis. So side 1 is the name of the feature, and I will pattern it around the outside of the part. Do 4 total of these at 90 degrees apart. Preview that to get a nice look. That looks correct. Hit finish. The beauty of patterning it is if there's any change that I want to make, so maybe I want to change my depth of cut increment or any other thing, all of the instances of that feature in that pattern will be updated. So now I'm at this point already, and honestly, if you really think about what I did, I'm just clicking some buttons, walking through the wizards, making some choices. I'm not selecting tools. I'm not setting my feeds and speeds every operation. I'm not worried about my depth of cut, all that stuff, because if I have a pre-configured set of machining attributes and they are loaded in this document, they will just simply update. So that concludes my presentation on FeatureCam and the turn mill. Autodesk FeatureCam makes this really quick and easy, and it's been my pleasure to share that with you today. So thanks for joining me, and we'll see you in questions and answers. Back to you, Eric.
Thank you, Andy. That was a fantastic look at the solution. It's just kind of mesmerizing watching the machine move that fast and do all those operations. It's definitely a lot of fun to watch you work. At this point, let's dig into the Swiss type lathes. We talked about this a little bit earlier, and these can be challenging machines because you often, as a machinist and you're running a machine, you want to be able to look in the window and you're trying to learn, how does the machine move? What's it doing? How's it operating? And then that's how you learn how to master the machine. But with a Swiss style lathe, there might just be so much happening in there, and there's fluid flowing around. There might be up to 17 different axes moving. And so it's really hard to get that understanding. But once you get this down and you start to learn something we call the order of operations and planning things out, you can have a ton of success with these types of machines. Let's look at what we have done with Autodesk Part Maker. It is a solution that was built for the Swiss industry, and it really delivers in terms of easy use and handling all the different things you're going to run into as you try to put parts on this machine. The first thing is you're going to get a myriad of different CAD files, 2D files, all kinds of different things that are going to be thrown at you. And we can bring those in and quickly build up the curve so that we can plan how we're going to tackle this on the CAM side of things. On the CAM side, we have a lot of different options. It's really pretty easy. Just get all of your operations into the system any way that you want. And once you've got the operations in there, we move into this patented process control section. And this is where you can drag and drop, move things around. You can do some trial and error. You can test different things. At the bottom, you can see the cycle times. You can see how much is on one turret or the other. And you can play around and really simulate what you're going to do. Whereas a lot of folks on a Swiss machine are just going to go and trial and error. Like I piece together this little bit of code and then this bit. And you're kind of doing a manual process for a machine that's built to really do things in a much more automatic and fantastic way. Lastly, let's put it through simulation. Let's test it. Let's see it in the real world. Let's get a little bit of comfort. And here you'll actually be able to see it. You'll be able to see how the machine moves. You can slow it down, speed it up, and work with it. One of the great things about the Part Maker solution is the post-processors. We've been at this for a while, and we have tremendous post-processors that are dialed into the machines. The post-processors are built up from the manuals from the machine so that they're cutting the same way the machine wants to. Lastly, we've just got a bunch of information that you can send down to the manufacturing team, to the machinist, anybody that needs to see the different parts and pieces coming together. There's plenty of documentation. Well, enough talking about it. Let's hand it over to Phil, and he's going to dig in and show you what this solution can do to reduce your risk and increase profitability in Swiss.
Autodesk Part Maker SwissCAM is a programming package that was designed from the ground up to run Swiss-style machines. Because of this, we have certain inherent capabilities that you don't find in other CAM packages. The first one is the patented process for creating tool paths, setting up construction planes, setting up my stock profile, and determining whether or not I'm working on the main or the sub spindle. This is called the setup dialog box. In the setup dialog box, we will set up the stock profile, the guide bushing parameters for the Swiss machine, determine whether we're working on the main spindle or the sub spindle, and then using predefined construction planes, setting the area of the machine where I need to work on the part. So for instance, if I'm going to be working with lathe tools, I need to be in a window or a construction plane that allows me to use lathe tools. In PartMaker SwissCAM, the setup dialog box will allow you to set up predefined construction planes. The system was designed by taking the component motion of a machine and breaking it down into specific, what we call face windows. You can call them construction planes or machining functions. Because we're predefining these face windows for you, you don't have to worry about your axis origins, whether you're working on the main or the sub. They will be correct. All you need to do is determine where on the part you want to work. Once that's determined, you select the correct construction plane. PartMaker sets everything else up for you. Let's look at the turning plane first. Under our turning window, we will face the part. We will do some OD turning. We'll thread the part, turn the second operation, run a back turning operation to set up for some milling, and then use the part off tool to cut the part off so that we can transfer it to the sub side. This process is done through the use of profile groups. So for facing, I simply tell the system this is a contour tool path. I'm working on the face of the part. I select my tool. When I apply and close the window, the operation is done automatically for me. PartMaker knows where the origin of the part is, so there's no need to select anything. We know where to cut the part. This is the 0 position on the part, and we cut the face at the 0 position. Next, we need to be working on the back end of the part to create these flats. That's going to require another face window. We cannot use live tools in a turning window, so we merely go back into the setup dialog box. And in this case, we're going to look for a machining function that allows me to take a tool and run it across the flats on the barrel to create the hex in this case. So I look for the window. In this case, it's a mill polygon window. By the way, this window was specifically designed for making hexes quickly and easily. Think of wrench flats, something like that. Okay, again, part of the inherent capabilities of the software. Once that is done, it will orient me into the correct construction plane, and from there, I can build my tool path. Looking down the spindle of the machine, I can just kick my part over, select the back end of the part surface, and translate that into the 2D window for programming purposes. Now, I can work off the solid if I want to, but in many cases, I want to see the translation into the 2D wireframe window so that I can adjust the geometry if I have to. Next, using the profile group, I create the tool path, determine what edge of the tool is going to be cutting on the wall, determine from the face of the part where the tool should be working, select the tool, apply and close, and then it's a matter of simply selecting the geometry that I want to cut. In this case, I'll chain the hex. Once that's done, in my 3D window, I can step the part through. I can show the guide bushing, the part, and the tool. And as you can see, we're just indexing the tool back and forward quickly and easily, creating the flats. The wrinkle on this part is this angled surface here. This requires B-axis motion. PartMaker does have the capability of creating 5-axis positioning and simultaneous 5-axis motion. To create the construction plane so that the tool is oriented parallel to the construction plane is quite a simple task in PartMaker. Again, we'll open up the setup dialog box. We'll set for a mill 5-axis plane and then just close the window. Next, I'll select my surface, and using my define face plane parameter set, I can quickly and easily tell the system I want a construction plane parallel to the face that I just selected. I select OK. Back inside the parameter group for the 5-axis plane, we've automatically set your indexing angles for the B and C angles on the machine, and also local coordinates. This is something that you do not have to worry about. We figure this out for you. It's a real time saver. Once we have that construction plane, I can view normal to find out what it looks like, take my geometry, project it into the 2D window, and from there, build my tool paths. In this case, I'm going to run an end mill across the flat. So I'm going to create a facing operation. Using the profile group to set up the tool path, I can tell the system what I'm trying to do. In this case, it's a contour mill. And I'm going to position the tool left, select my cutter, again, close my window, and then select geometry so that I can run the tool path. As you can see, we will position for a 5-axis plane. And setting up 5-axis planes in PartMaker, as you just saw, is a very simple task. Doesn't take a lot of math at all. Next, looking at the part, we've got the hex done, we've got the 5-axis plane done. There's some work that needs to be done on the back end of the part, and this is going to be taken care of using the sub spindle to machine with. So back to the setup dialog box. I'm creating a turning window. It's going to be a new sub spindle turning window. And again, working between the main and the sub spindle in PartMaker is as easy as it gets. Once you set the sub spindle and you set the machining window, we automatically flip the part around and put you in a sub turn operation. As you can see, the part's flipped around. The axis shows the 0 position for the subside face. So here we're actually doing a bit of facing on the subside. We're using a cycle group so that I can spot, drill, and tap under one command. If I open this up, you'll see that I can create tool paths and group them together to create single cycle groups. In this case, I'm going to spot, drill, and tap. I do not have to set these tool paths up separately. I just tell the system what I need from it, set up the tool paths, close the window, and again, in a turning window, the only place you can drill is through the center of the part. Part maker understands this and automatically positions it correctly for you. Once we have our list of tool paths done, think of this as the operations needed to run the part, but not the order of operations. That comes next with our process table. This is the second patented process that part maker uses. And what it does is it allows me to quickly and easily look at my tool paths, check my tools. I may have to update a tool. I can just simply click on a tool and edit it on the fly. I don't have to clear out the process table, don't have to go back to the tool paths. The editing capabilities in this software are extremely easy to work with. So in this case, the tool paths look good. Turn it, thread it, second turn, back turn, do the end mill, 5-axis. Yeah, let's put this on before we do the hex. So I'm not going to have to reorder this operation at all here. We can always open up an operation, rename tooling, add feeds and speeds. If I'm working with a more complex tool path like a turning operation, it allows me to set up my constant surface speed if I need to, set up my multi-coolant parameters, run output profiles as programmed or compensated. Once that's set up, the right side of the screen is where I can synchronize the main and the sub spindle to work together. In PartMaker, we call this visual synchronization. Simply select your first button for the facing operation. This is a mode button. And if you look through here, I have a main spindle mode, I have a sub spindle mode. The main spindle right now is using a tool, which in this case is facing. If I want the sub spindle to be working with the main spindle at the same time, I just go to the sub spindle mode and I read through what I want the system to do for me. In this case, if I'm machining with one tool on the main, I want to be machining with one tool on the sub. As you can see, we're updating the process so that these tools will work together. Since I want all the main spindle operations to do this, I'll set the modes for all the main spindle operations with a single mouse click. And as you can see on the right side of the page now, our modes buttons are updated. M1, S1 basically means one tool on the main, one tool on the sub. Now on the sub side, we don't automatically update the sub side. If we did that, we'd only allow for one sync state. But there are many cases where you'll have to run tools synchronized and then run tools separately and then come back in and resynchronize further down the process table. So we allow for the synchronizing to be separated by the main and the sub. It's simply a matter of picking the first sub button. I'm machining with one tool on the sub. I want to be machining with one tool on the main. And since I want all the sub operations to do the same thing, I'll modify the modes for all the consecutive operations. At this point, I've got everything set up so that the machine can work simultaneously on the main and the sub. I'm just going to go ahead and click the synchronize button. You'll see a sync group pop up. Just the number one in this particular group because we're only using a single synchronized state. The last thing I want to do is go to my cutoff process, and I want the sub spindle to come up, grip the part, and support it while I'm parting it off. This accomplishes two tasks. The first thing it does is cut the part off. The second thing it does is it gets the sub spindle set up to receive the part, so when it retracts to its home position, it's ready to start machining. So let's go ahead and do that. The follow support function is to support the part during cutoff. And I'm going to put a grip length in how far I want to grip on the part before I part it off. In this case, I'll use 0.95. Select OK. Now let's run our simulation. Simulation in PartMaker can be done in two styles. What you're looking at here is our full machine simulation kit, showing all the tools in their correct position, the main spindle, the sub spindle, the guide bushing, the bar stock going through the main spindle, and the components on the machine. We also have a simplified version that allows the user to quickly and easily just establish where his tool paths are. So let's run in simple mode first. And we'll start by cutting on the main spindle. Now the process is always to run the main spindle first and then transfer to the sub spindle. Once that's done, you'll see both tools working at the same time. All this work that we're doing on the sub side is considered to be, I don't know, put it this in quotes, free work. And the reason we call it free work is because while the main spindle is working there, we're getting the sub spindle to work here. So we're saving all the time captured on the sub spindle and using it while the main spindle is running. Okay, let's take a look at the full machine simulation and see how that differs. In full machine simulation, you can check for interferences, you can check to see your tools are lining up correctly, and you can also check the component motion between the main and the sub spindle on your machine. So let me just tilt this so we can get a view of the stock, and let's run the full machine simulation. Swiss machines are very complicated. Their views are very complicated. Some cases you will definitely want to just keep on rotating the view around so that you can still keep the machine and the stock in view. As you can see, both main and sub are working together, saving all this time on the sub side. Okay, the system will run the part through basically 1.5 times. Okay, so you'll see the main spindle transfer the sub and then it'll pause. Although I can put this in a loop and just run it like I would on the floor. And from that point, we can show the finished part. I like what I see on the finished part here. The thread looks good. The operations around the part look good. So I can close my simulation. And now using my post processor, in this case, the machine I'm working on is a Star SR20R4 with B-axis capability. So I'm going to generate some code. There's two ways of generating NC code. The first method is just to view the code on your screen so you can check it out to see how things are going in the code. The second method is to actually generate a file that you will then send to the machine either through a DNC system or a UBS stick or an RS-232 system, whatever you're using to communicate to your machine with. So to view the code, I'm just going to go to my quick NC program view. It opens up my post options dialog box. This allows me to add functionality into the code. For instance, air blast and cutoff detection are features within the machine. The air blast actually clears the sub spindle out before it picks up the part. The cutoff detection makes sure the blade's in the correct position. Once I've got these filled out, it's going to generate code for me. We always split our code in the number of channels that is required by the machine. In this case, this is the main spindle code, and this is the sub spindle code. If I like what I see, I can right-click, generate an NC program, view the NC program by launching an editor or just viewing the program. In this case, I launched the editor, and then I can go into the program, add information, maybe a few comments for the operator, something like that, and I'm done. So as you can see, the SwissCAM product from Autodesk has taken the guesswork out of a lot of Swiss programming. You will not have to worry about your construction planes where you're working on the main or the sub spindle. We've created predefined construction planes so that you don't have to worry about your axes. We've also built specialty planes for operations like hexes around the back of the part, that kind of thing. All in all, one of the best SwissCAM packages you'll ever run into. Now, as far as what we can support, just name any Swiss machine that's being developed on the planet currently, and we will have a post for it. We have over 1,000 post processors for Swiss machines. Let's just take a look at the Citizen, for example. The A models all the way through the R models, and each model is represented within the package, an M16, an M120. So whatever machine you have, we'll have the post for it, and we'll be generating code for you. That's it. Eric, back to you.
Thank you, Phil. It's always great to watch you doing these demonstrations, see the machine move, and you're taking a very complex topic and making it easy. And I thank you for that. The next area of our presentation we want to get into is just the advanced techniques, the integrations with the system, the ability to take it from just being a turning solution and do so much more with FeatureCAM and PartMaker. These are some of the top add-ins that the system has. The nice thing about these is they're open source and you can build them, you can share them, you can get additional folks with coding expertise to dig into them. And a lot of people have done that with the solution to really extend it.
Hi guys, it's Andy again. I want to just talk about this a little bit more. So these are just a few of the kind of key ones here. We can create setup sheets. They are fully customizable. You can create them with an HTML or Excel versions. You get a nice overview of what you need to send out to your setup person or for yourself to remember which tools go where, what the part looks like. It's really, really handy. The verification, you can send the code out to all the verification type of softwares, whether it's Complete or Vericut, NC Simil, etc. So that's nice to be able to do that and just double check everything. FeatureCAM's probing abilities are really, really done with great precision and also very handy. So you can do everything from setting your setup in a specific location, updating the location of that setup. You can update tool lengths after probing the depth and seeing if the feature is where you expect it to be. If not, you can update the tool length offset. You can also just take measurements to verify the parameters, setting the tolerances that you want. And if there are any issues, you can even prompt the process to stop, or you can just print out the results, whatever it is you need for those.
Yeah, Andy, I'm really impressed with these. It's interesting. We have a lot of customers calling in and wanting to do probing, and it's great to have this option to help them take it to the next level. I've also just been blown away about how many different add-ins there are. And this is just some of them. Well, this is definitely more than half, but we couldn't fit them all on one slide very easily. What are some of these that are maybe some of your favorites? I know I saw one on the port cavity recently, but what are some of your favorites?
So the port cavity macro, as you mentioned, is really nice because you can take advantage of existing programming knowledge, the way you like to machine ports if you have those in a manifold or something. And you can actually set it up the way you want to machine it. And so the next time you have a similar part, you can actually run that. It does feature recognition similar to what I showed, but it will actually apply the tool paths exactly the way you like to machine those ports. That's one of the really nice ones. I also like the probing one that I mentioned before. That's really, really a great one to give you the ability to take advantage of probing on your machine. Over on the left-hand side, we see some of these 5-axis ones. That one's really nice as well. So FeatureCAM, I know we've talked about turn and turn mill specifically today, but FeatureCAM does everything from simple 2D machining all the way through 5-axis simultaneous, advanced turn mill, which I showed you today, wire EDM, all of those. So this 5-axis one, there's 2 of them at the upper left where it'll actually create a setup on the angle that you need it, just looking at the model and detecting a flat, and it automatically slaps the setup where you want it. And the second one will actually create a feature after it does that. So that's actually one of my favorites as well. And then over in the utilities, the import vise, if you haven't seen that one, you should actually go Google that. Just Google FeatureCAM import vise and go watch the video on that. That's really amazing. So those are some of my favorites, Eric.
That's great. And it's so neat too to see people taking these, making their own, customizing them even further to get more efficiency. Here's one that we had started talking about, but this is another key area that we wanted to address in this presentation today is manual setup. A lot of this can sometimes be time consuming. This is where a lot of shops lose time and they add a lot of risk into the situation. And so what we've been talking about, what Andy was just talking about, the automated setup and verification. Let's go ahead, let's get probing involved. Let's reduce the setup time. And again, part of our whole presentation is why put it into multiple different machines? Let's put it into one machine and let's get rewarded for that and making sure it's a good process. The verification of the part accuracy is also really important. Sometimes you've got a waterfall effect and you want to, at each step in the phase, you want to make sure that, hey, I've got the part, the first operations happen correctly. Now we want to move downstream with confidence and reduce our scrap and waste. Another great thing here too is the collision avoidance. It's really ideal as you get into more complex situations where you want to have some confidence that I'm not going to have a problem. I'm not going to blow up part of the machine, hurt my vices and the investments that you've made into this business. This is a way to make sure that your investment stays strong and you don't have a setback. Talking about clamps and fixtures, Andy talked about one of his favorites on the last list, but also just there's a predefined library built in and you can pull these in and really help yourself in the safety area of this to make sure that they're accounted into all the work and the moves that the machine's going to make. Last is just getting the machine and simulation limits together. Confirm what it is that you think is going on. Make sure that you've got that confirmed several different ways before you go to cut the part. A simulation doesn't cost you anything but time. And it's nice you can go in here and some of these you can speed up, you can slow down, you can look at only the parts you're worried about and make it an efficient use of your time. So overall, we've talked about these solutions and how software is really going to reduce the risk for you. And this is where we really dig in and we talk about this being a comprehensive solution for the whole team. What you have at the end of the day is if you start using the automation capabilities and building in the tool libraries and the machines and getting everything set up, you're kind of getting your best programmer for your whole team. So for example, if someone's really good at cutting a certain type of part or a family of parts, go ahead and have that person program up that part in the very best way. Then let's bring those standards back to the whole team in a way that everyone can use them. And this is how you really ramp up your results with a solution by building a team of your best programmers. It's also not to be lost is it's really easy to bring someone into a situation where automation's already running. So you have a new person coming in, they have a chance where they can go through and see how all this is happening, learn the processes you have at your shop, and get up to speed much more quickly. In this team building process, it's so important, the human capital and the capabilities. Humans are our most programmable, the widest variety of things that they can do. And so you really want to invest in them. And these solutions is a way to invest in them. And you think about there's jobs that maybe you could be quoting or work that you could be working on. So if you have a slow time, take those bids and get someone working on it virtually. You don't have anything to lose by getting into this virtual environment and building up skills. The other key to this is as people grow, make sure you have a peer review process in place so that someone who's taking a new risk and moving into a new area, you don't want to shortchange them and put them in a situation where they can fail. Make sure that they understand and have clear guidelines of who's going to step in and help them so that they can try something new and something more complex. You've got to be patient sometimes and build this up over time. We're a big fan of making a unique plan for every programmer. One of the things we'd like to do is set up learning plans for the different programmers in the shop and help them build a plan for where they want to be over time. It's also key, we've learned overall, is that autonomy and the ability to make your own decisions is a key factor in how well you're going to like working at the shop that you're in. So if you can build up these skills and the trust at some point, you're actually making it a better place, a more fun place for people to work. So in conclusion, we started off here talking about the risks, and it's exciting to think about doing jobs that are more profitable. and making more money, but it's hard to look at the risks. And I think that we've shown you very nicely today is that we can, with the solutions that we have, reduce the risk on turn mill to make it more profitable for you. We can do the same thing for Swiss. And when you look at these big areas where your shop can struggle, we're addressing a lot of those. We're reducing programming errors. We're helping you get the right tools and settings through simulation and analysis and looking at things ahead of time. We're able to do offline programming where we aren't tying up the machine so that your machine efficiency goes up. And we're able to start working on that skill gap by using software to expand and increase the learning rate for folks on your team. So thank you so much for joining us and for listening in. At this point, we're going to move into the Q&A, and we look forward to your questions.